In this video, I will teach you how to do triangle similarity proofs. Please remember that ultimately there are only three ways to prove that two triangles are similar. It will either come down to side-side-side similarity, angle-angle similarity, or side-angle-side similarity. If you have side-side-side similarity, that means that you have three pairs of sides that are proportional. Proportional means that if you make fractions out of corresponding sides, you get the same number all three times. For example, 5 over 10 equals 3 over 6, which equals 6 over 12. Alright, of course, all of these simplify down to 1/2. So we have three pairs of corresponding sides that are proportional. Angle-angle similarity simply means that we have two pairs of congruent angles. So that's all it takes for two triangles to be similar. And finally, side-angle-side similarity. If we have two pairs of corresponding sides that are proportional, like I described up here, and a pair of congruent angles, then it will be side-angle-side similarity as long as the congruent angles are between the sides. Alright, the angle has to be in the middle between the sides that are going to be proportional. Alright, and again, when I talk about these sides being proportional, I'm saying that if I make little fractions out of them, like 5 over 10 and 6 over 12, each of those fractions will be equal to each other. That's what it means to be proportional. Alright? They're both 1/2. So look at problem number 1. We are given parallel lines. Okay, it's already marked with these little arrows. These little arrows mean that the lines are parallel. So just to draw your attention, I'm going to highlight it. This line is parallel to this line. Parallel lines lead to congruent angles, which is what's about to happen. And it's because when you take parallel lines and you cut them by a transversal, I should do it the other way first, because it makes a nice letter Z, as in zoo. I haven't been to the zoo in a long time. And when you have those parallel lines and it makes a nice letter Z, then the corners of the Z are alternate interior angles, and they will be congruent. Okay, so right there, I know that angle A is going to be congruent to angle E. And the reason is because alternate interior angles are, well, let's just say the alternate interior angles theorem. Alternate interior angles theorem. And which simply says that if the lines are parallel, alternate interior angles are congruent. But that's a quick way to say it. But it doesn't have to be a proper Z. It could be a backwards Z. Wait, I erased too much. Okay, if I look at the other transversal forming this backwards Z, okay, those are still there, I'm going to get another pair of alternate interior angles. So this corner of the backwards Z is going to be congruent to this corner of the backwards Z. So angle B is congruent to angle D. And it's going to be the same reason. Alternate interior angles theorem. Okay. And guess what? That is enough information to say that the triangles are similar. Which one of these three things is it going to be? Side-side-side similarity, angle-angle similarity, or side-angle-side similarity? Well, all we have is a pair of corresponding angles, angle-angle. So these triangles will be similar by angle similarity postulate. And I need to go ahead and say the similarity statement. Okay, ABC is similar to EDC. Okay, this little note here is letting us know that this is the same question. This is the same picture as question number 1, but the third row of the proof is different. So we will watch out for that. So again, we are given these parallel lines. So just like we did before, we could look at this transversal forming a Z, and we knew that these angles would be congruent because of the alternate interior angles theorem. So angle A, once again, will be congruent to angle E. All right, I think I'll write it out this time. Alternate interior angles theorem. All right, I just want to make sure you know what I'm saying when I write these little abbreviations. Okay, anyway, last time I drew the other transversal so we could talk about angle B and angle D being congruent. But that's not what they have. This time they're talking about angle DCE. Okay, angle DCE is this angle right here. Well, guess what? That angle is going to be congruent to angle BCA. Angle BCA. Do you remember why these two angles would be congruent? These are vertical angles. Okay, so vertical angles theorem. Okay, vertical angles are congruent. And again, we can say, we can make the similarity statement. Same as before. So triangle ABC is similar to triangle EDC. And again, it's going to be angle similarity. All right, please take a look at problem number 3. Again, we are given these parallel lines. Bam and bam. These lines are parallel. Repeat after me. Parallel lines lead to congruent angles. Very good. Parallel lines lead to congruent angles. So, this is a different situation though. There are two situations where parallel lines give you congruent angles. Sometimes you can form a Z, which is what we were doing right here, some kind of a Z, even if it's backwards. And sometimes it will form an F. Okay, for example, if I use this line as the transversal, can you see that this as an F that's like leaning over to the right? Well, the corners of that F are corresponding angles, and they are going to be congruent when the lines are parallel. Okay, so angle CDE, all right, that's the first corner of the F, is going to be congruent to angle CAB. So angle CAB. And that is the corresponding angles postulate. Okay, now we could easily make a backwards f in a similar way that I made a backwards z on problem number 2. If I put the other side of the f here instead, if I use this as the transversal, can you see this as a backwards f that's facing up? So, once again though, the corners of the f are going to be corresponding angles, and if the lines are parallel, they are congruent. Okay, so angle CED, that's this first double angle, is congruent to angle CBA. So angle CBA. And the reason is the same. Okay, I think I'll abbreviate this time just to show you that it's okay to abbreviate. Alright, I'm going to say corresponding angles postulate. Okay, you can abbreviate like that. And once again, we are going to make our similarity statement. Triangle ABC is similar to triangle, let's see, ABC, and then DEC. And once again, the reason will be angle similarity, because that's what we have, two pairs of congruent angles. Once again, we are warned that this problem is the same as the previous problem, but the third row is different. So watch out for that. Alright, but it's starting off the same way, CDE. So we are going to use the fact that we have parallel lines. Hey guys, do parallel lines lead to congruent sides or congruent angles? Congruent angles. Alright, parallel lines do not give you congruent sides, they give you congruent angles. Because if you make them into an F, you have corresponding angles, which will be congruent if the lines are parallel. So, this is what we did last time. So, angle CDE is congruent to angle CAB. Okay? And that was the corresponding angles postulate. Alright, but now they're saying angle C is congruent to something. Well, I hope you see that angle C is being shared by both triangles. Alright, angle C is an angle of the small triangle, and angle C is also an angle of the larger triangle, but it's the same angle. So guess what? Angle C is congruent to angle C. And when you have a shared angle or a shared side, that is called the reflexive property. Okay, when you get to say that an angle or a side is congruent to itself because of the way it's being shared, that's the reflexive property. So once again, I can say triangle ABC is similar to triangle DEC. Okay, and again, it's going to be angle similarity. We're getting a lot of use out of good old AA similarity. Alright, switching it up for a minute, getting away from actual proofs for a bit. Look at problem number 5. We're being told that these triangles are not similar. Alright, if we didn't do some calculations, we might think that they would be similar by side, 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 just because we have all three sides here and we have all three sides here. But if it's going to be side, 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 the corresponding sides have to be proportional, meaning if you make fractions out of the corresponding sides, they should all be equal to each other. So we can't assume, we have to check. Now, how do we know which sides are corresponding? This could be rotated any kind of way. Well, here's what you have to do. You have to look at the size of the numbers. Look at the first triangle. What's the biggest number? 15 is the biggest. Look at the second triangle. What's the biggest number? 10 is the biggest. So these are corresponding sides. So let's go ahead and make a fraction out of those. Okay, yeah, let me use my small pen for a second. Okay, so I'll just do 15 over 10. Okay, now, in the first triangle, what's the smallest number? 9. In the second triangle, what is the smallest number? 7. So these should be would be corresponding sides. If these were similar triangles, these would have to be the corresponding sides. So let's check that out. So I did 15 over 10, so I'll have to do 9 over 7. So if these triangles are similar, then these ratios, these fractions, should be the same. 15 over 10 does reduce. They're both divisible by 5, so that would reduce down to 3 over 2. But 3 over 2 does not equal 9 over 7, which does not reduce. So that means the sides are not proportional. So that means these triangles will not be similar. So I'm just going to write down a sentence. So there you go. The triangles are not similar because the corresponding sides are not proportional, as I showed with my calculations. Now these triangles are similar. Which reason proves it? Well, I don't have any angles showing, so that means it can't be angle-angle similarity or side-angle-side similarity, because I'd need some angles. So the only possibility is side-side-side similarity. Okay, so we know it's going to be side-side-side similarity because they told us they are similar and it can't be either of the other two. But however, we must show our calculations to prove it. So for side-side-side similarity, again, the corresponding sides must be proportional. So I need to decide which sides are corresponding. The biggest side on the first triangle is 15. The biggest side on the second triangle is 10. So if I make a fraction out of those, that's going to be 15 over 10. Okay, the smallest side of the first triangle is 9. The smallest side of the second triangle is 6. So those would be corresponding. So that would be 9 over 6. And then the remaining side is 12, and the remaining side is 8. So that would be 12 over 8. So the question is, are these equal? We already know that these triangles are similar, so I know they will be equal. But let's go ahead and reduce. These are both divisible by 5, so this reduces to 3 over 2. These are both divisible by 3. That gives us 3 over 2. These are both divisible by 4. So that will give us 3 over 2. Alright, number 7, we are told that these triangles are not similar. Why not? Use calculations and words to explain. Well, I have a pair of angles that are congruent. Even though they were not marked from the beginning, that is okay. Vertical angles are always congruent, so I can go ahead and mark them. Now, these angles are between pairs of sides that are labeled. So it seems like there's a chance that it could have been side angle side similarity. But in order to be side angle side similarity, the corresponding sides have to be proportional. Meaning, if I make fractions out of them, I should get the same answer. So again, from the first triangle, the smaller number is 14. Boom. From the second triangle, the smaller number is 12. Boom. So those would be corresponding sides if the triangles were similar. So that would make 14 over 12. Okay, and now they're telling me that they are not similar, so I can go ahead and know that these are going to be not equal. But now, looking at the 20 and the 16, of course, would have to be the other pair of corresponding sides. So that's going to be 20 over 16. So when we reduce, both of these are divisible by 2. That's 7 over 6. Let's see, both of these are divisible by 4. So that's going to be 5 over 4. So these are both completely reduced, and 7 over 6 does not equal 5 over 4. So now I'm just going to write a little sentence. I actually cheated and copied the same sentence from above. It's the same reason. The triangles are not similar because the corresponding sides are not proportional, as you can see. Last one. These triangles are similar. Which reason proves it? Well, just like we were saying before, even though the angles are not pre-marked, these vertical angles will always be congruent. So we can go ahead and mark them ourselves. Now, we don't have any other congruent angles. So that tells me that it cannot be angle-angle similarity. So I can forget about that. We don't have any other sides. We don't know the lengths of either of these sides. We only have 2 pairs of sides. So it cannot be side-side-side similarity. All right, it takes 3 sides for that. So it's going to have to be side-angle-side similarity. All right, we already know they are similar, and so that's the only one that's possible. But now it's time for our calculations, because if it's going to be side-angle-side similarity, the corresponding sides have to be proportional. Remember, number 7 and number 8 really look the same at a glance. We have numbers in the same places and we have the same vertical angles. But yet number 7 is not similar and number 8 is similar. So it's absolutely critical that you check the ratios of the corresponding sides and see if they're equal. So I'm purposefully showing number 7 as I do this so you can remember what I did before. So 15 is the biggest side, all right, of the first triangle. 16, oh, did I really just say that? Wow. 15 is not the biggest side. You know why I said that? It's all bold and big. The number itself is printed bigger. So that's on whoever made this worksheet. But 20, of course, is bigger than 15. And then 16 is the biggest side of the second triangle. So these would be corresponding. So if I made a ratio out of that, it would be 20 over 16. So that's going to have to equal the other one. So I'm going to go ahead and put that equal sign down. So of course the other pair has to be the 15 and the 12. So 15 over 12. Both of these are divisible by 4, so that's going to be 5 over 4. Both of these are divisible by 3, so that's going to be 5 over 4. So we got the same number both times, so the corresponding sides are proportional. So we have 2 pairs of corresponding sides that are proportional, and the included angle is congruent. So there's your side-angle side similarity. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.